December 15th, 1944. Rechlin Testing Facility, Germany. A bitter winter wind swept across the airfield, carrying with it the fading echoes of a war Germany was already losing, though few dared admit it aloud. Inside Hangar 4, under dim yellow lights, a group of engineers in gray coats stood around a machine that symbolized the industrial might of their enemy, a captured American P-47 Thunderbolt. The aircraft was enormous, heavy, and alien in its simplicity. Its metallic skin bore bullet holes from its final combat mission. But the real treasure was what lay beneath that skin. The complete blueprints, maintenance manuals, and most importantly, an intact Pratt & Whitney R2800 double Wasp engine. Oberingenieur Klaus Becker, a man known for his precision and methodical mind, led the inspection. He had spent 2 weeks with his small team, documenting every single component of this machine. They measured the curvature of each wing panel, the rivet spacing along the fuselage, and the alignment of every hydraulic line. To Becker, the R2800 engine was both a masterpiece and a mystery. An 18-cylinder radial design producing over 2,000 horsepower, an engineering marvel built with industrial precision that Germany's own factories struggled to maintain even on smaller engines. He noted every dimension, every material composition, and every manufacturing detail. Cylinder bores 146.05 millimeters. Variance between cylinders less than 0.02 millimeters. By German standards, that was unheard of, nearly 5 times tighter than what even BMW or Daimler-Benz could achieve on their best days. But what truly unsettled Becker was not the precision, it was the consistency. Every part was identical. Every surface finish mirrored perfection. It wasn't craftsmanship. It was replication on a scale Germany couldn't imagine. These engines weren't built by artisans. They were produced by machines designed to produce. And that realization sent a cold chill down Becker's spine. When he opened the maintenance logs, the truth hit harder than any Allied bombing raid. According to American records, mechanics, not engineers, not master craftsmen, but ordinary factory-trained workers, replaced entire 2,000 horsepower engines in 2 hours. Becker froze at that line. 2 hours. His Luftwaffe ground crews needed 3 full days to replace a BMW 801 engine on the FW-190, and even then, alignment issues and fuel leaks were common. Yet here was proof, documented and verified, that Americans could swap an R2800 as if it were a car engine. He moved to the next page. Every engine part had a serial number. Every bolt, washer, and gasket bore a small marking, a code indicating factory origin, batch number, and inspection certification. It was manufacturing turned into mathematics. Then came the crate, a simple wooden box labeled Spare Parts, P-47 Engine Module. Inside were hundreds of components, spark plugs, pistons, cylinder heads, oil fittings, all tagged, numbered, and cross-referenced. Becker held one in his hand, a small aluminum bracket, barely 50 grams. Stamped on it were the markings AN 7743A, MILB 5687, Lot 4421, QC Pass. At first, it meant nothing. Then, as he cross-referenced it with the manual, he realized what he was looking at. AN, Army-Navy Joint Specification. MILB, Military Standard Document. QC Pass, Quality Control Approval. That one small piece carried its entire history within a few numbers. It could be replaced by any identical part from any factory across America. A bracket made in Ohio would fit exactly where one from California did. No adjustment, no filing, no compromise. It was the first time Becker understood the true secret of American power. It wasn't just technology. It wasn't even innovation. It was systemization. Germany could design brilliance. America could mass produce it. The Americans had turned their entire industrial culture into a weapon, an invisible factory network that stretched from Detroit to Seattle, each working in perfect coordination, each following the same standards, each delivering precision that didn't depend on genius, but on process. That was their real advantage. As Becker studied deeper, his admiration turned to dread. The manuals were unlike anything he had ever seen. They weren't written for engineers. They were written for anyone. Step-by-step procedures, illustrated diagrams, torque values for every bolt, troubleshooting flowcharts that looked like machine logic. It was a guide that transformed any worker, farmer, teacher, store clerk, into an effective aircraft mechanic within weeks. Becker turned to his assistant, Friedrich Weiss, and muttered quietly, "The Americans have built a system that doesn't require expertise. It only requires obedience to procedure." Weiss nodded silently. He understood what that meant. Germany could never replicate it. For years, the German war machine had relied on craftsmanship, on master machinists, toolmakers, and engineers who could shape metal with skill and intuition. But those men were vanishing, killed at the front, or trapped in bombed-out factories. Their replacements were untrained laborers working in underground facilities, producing components that rarely fit without reworking. Meanwhile, across the Atlantic, America was training millions of new workers, and not just training them, but giving them machines and processes that guaranteed consistency. Becker scribbled in his notebook, "This is not engineering, it is manufacturing science. They have industrialized perfection." He didn't know it yet, but that single insight would define the rest of his report, and his conclusion would terrify those who read it. Because for the first time, a German engineer understood why Germany could never win this war. The next morning, Becker's report began to take shape. He sat inside his office, a small, unheated room within the testing facility, surrounded by sketches, photographs, and disassembled American components laid neatly on the table. His fountain pen moved quickly across the pages, methodical, relentless, as though documenting a scientific discovery rather than an enemy weapon. He titled it Technische Analyse des Amerikanischen Jagdflugzeugs P-47 und seiner industriellen Fertigungsmethoden. Technical analysis of the American fighter aircraft P-47 and its industrial production methods. But what Becker was truly studying was not the airplane, it was America itself. The first section was purely technical. He described the R-2800 engine in excruciating detail. Twin-row, 18-cylinder configuration, air-cooled, radial type, with twin-stage supercharging and an intercooler that operated flawlessly at both low and high altitudes. He wrote, "The American engine demonstrates extraordinary tolerance management. The assembly of the crankshaft and master rods allows continuous operation at 2,700 RPM for 200 hours without measurable wear. Comparable German engines under ideal conditions rarely exceed 40 hours before major servicing." He paused. He had just confessed, in writing, that the American engine not only equaled, but surpassed the technological standard of the Luftwaffe's best. He turned to the metallurgical samples, A handful of broken piston rings, connecting rods, and bolts were carefully tagged. He had sent them to the lab 2 days earlier for analysis. The results were astonishing. The Americans were using alloys he had never seen, blends of nickel, chromium, and molybdenum that offered high fatigue resistance even under extreme thermal stress. But the real shock wasn't the alloy itself. It was the uniformity. Each sample had identical hardness values. Each bolt had the same grain structure. It was as if they had all come from the same forge, the same batch, the same perfect machine. In Germany, such precision was impossible. Every batch of steel came with its own quirks, its own impurities, its own subtle imperfections. German engineers compensated with skill, adjustment, intuition. Americans compensated with standards. Every piece of the P-47 was stamped, measured, verified, catalogued. The entire aircraft was a puzzle built from interchangeable parts. If one was damaged, another could replace it without any custom fitting. This was revolutionary. Becker's assistant, Weiss, entered the office carrying a set of photographs captured from Allied air raids. He laid them on the desk, images of vast American factories. Ford's Willow Run plant, Republic's Farmingdale assembly line, Pratt and Whitney's East Hartford complex. Each photo was a cathedral of industry. Becker studied one closely. Willow Run, over a mile long with more than 42,000 workers producing one B-24 Liberator every 63 minutes. He read the caption aloud, his voice trembling slightly. 63 minutes, one bomber every 63 minutes. He leaned back in his chair, stunned. Germany's entire Messerschmitt production, even at its peak, couldn't match that output in a week. Becker understood, at that moment, that the Americans weren't merely building machines. They were building systems that built machines, factories that created tools to make other factories. A recursive empire of industry. He added another line to his report. The Americans have achieved what we theorized but never realized, the weaponization of production itself. Their engineers do not only design machines, they design systems of reproduction. That sentence would later be quoted in post-war Allied intelligence summaries as one of the most prophetic technical assessments of the entire conflict. Weiss, still looking at the photographs, whispered, "If they can build one bomber every hour, then how do we fight that?" Becker didn't answer. He didn't need to. The answer was written in the air outside. The endless drone of Allied bombers crossing the sky, their contrails stitching across Germany like a white scar. Later that evening, Becker was granted permission to speak with General Feldmarschall Milch, Inspector General of the Luftwaffe's production division. The general was known for his bluntness and obsession with efficiency. Becker entered with a stack of documents, his analysis, his sketches, and the American manuals. Milch skimmed through them, his expression shifting from curiosity to irritation. "You're saying the Americans can do this," he said flatly, pointing to the line about engine replacements. 2 hours? Impossible. Becker replied quietly, "Herr General, it is not only possible, it is documented. The Americans have standardized their aircraft to the point where even unskilled personnel can perform complete engine swaps. The aircraft was designed for it." Milch frowned. "Then we must copy this." Becker hesitated. "We cannot, sir. Not without rebuilding our entire industrial philosophy." Milch looked up. "Explain," and Becker did, carefully, methodically, painfully. He explained how German factories were built around artistry, not automation. How every FW-190, every BF-109 was slightly different. How even identical parts often required hand-fitting, small grinding, and adjustment. He spoke of missing tolerances, supply chain fragmentation, and inconsistent alloys. He compared Germany's production chaos to America's assembly line order. When he finished, Milch sat in silence. Finally, he said, "So you're telling me, engineer, that we are losing not because of design, but because of discipline?" Becker nodded. "Yes, Herr General. Discipline and documentation." Milch leaned back and sighed heavily. "Then this war is already lost." Becker didn't respond. He didn't have to. He gathered his papers, bowed slightly, and left. Outside, snow was falling again, soft, quiet, relentless, covering the airfield like a shroud. He stopped by the P-47 one last time, running his hand along the cold metal of the engine cowling. This machine, he thought, was more than a weapon. It was a message written in steel, oil, and process, that the age of individual craftsmanship was over. The age of industrial democracy had arrived, and it was unstoppable. When Becker submitted his final report in early February 1944, it was quietly archived by the Luftwaffe's Technical Evaluation Division in Berlin. Only a handful of officers ever read it. Most dismissed it as overly analytical, too philosophical, one colonel scribbled in the margin. But a few saw what Becker saw, that the war was no longer about who had the fastest fighter, but who could replace that fighter faster. Weeks later, a copy of Becker's report found its way into the hands of Albert Speer, Minister of Armaments and War Production. Speer, unlike most of the Nazi hierarchy, understood industry at the cellular level. He had toured American plants before the war. He had seen Ford's conveyor belts and the massive stamping presses that spat out car panels faster than human hands could count. When he read Becker's analysis, he called it a technical prophecy written too late. He summoned Becker to Berlin. Becker arrived at the Reich Chancellery at dawn, exhausted and anxious. Speer's office was cavernous. High ceilings, steel filing cabinets, blueprints stacked in rolls. The minister greeted him with an engineer's handshake, firm, deliberate, but not theatrical. "I've read your report," Speer said, motioning for him to sit. "You're describing an American miracle. But you and I know there are no miracles in engineering, only systems. So, tell me, what is their secret?" Becker opened his folder and spread out diagrams of the American supply chain. Lines connected icons, steel mills, aluminum smelters, sub-assembly plants, training schools, logistics depots. He pointed to the intersections. "This is the secret, Herr Minister. The Americans are not improvising production. They are orchestrating it. Each part of their system speaks to the others through documentation, standardization, and trust. The result is not chaos, but rhythm." Speer studied the diagrams. "So our problem is rhythm." Becker nodded. "Our factories fight against each other. Competition between companies, between ministries, between egos. Theirs cooperate. They even share blueprints across firms. They build redundancy into the process. If one plant is bombed, another takes over seamlessly." Speer leaned back, frowning. "You're describing socialism, engineer." Becker smiled faintly. "No, sir. I'm describing efficiency." For a long time, Speer said nothing. Then, quietly, "If we lose this war, it will not be because of bravery, or even technology. It will be because of arithmetic." By spring, Allied bombers were turning the Ruhr Valley into smoke. Entire production blocks vanished overnight. Germany scrambled to move its factories underground, caves, salt mines, tunnels. Production continued, but Becker saw what was happening: disintegration. Each relocation meant lost documentation, lost tolerances, lost standardization. Each aircraft that rolled off the line was slightly different, slightly imperfect, slightly slower. Meanwhile, the Americans were accelerating. At Republic Aviation, the P-47 was being built in 3 separate factories simultaneously, all synchronized by standardized blueprints and telegraphic coordination. A new aircraft could be assembled by semi-skilled workers trained for only a few weeks. Women, farmhands, students, all part of the same vast industrial organism. In one famous sequence of photos Becker studied after the war, a single P-47 wing was seen traveling from Connecticut to New York to Indiana, across 3 factories, and every bolt hole lined up perfectly when it arrived. That, he realized, was victory, not the pilot's courage, not the engineer's genius, but the alignment of holes drilled hundreds of miles apart. As 1944 turned into 1945, Becker's world collapsed. Berlin burned. The Reich fell. He destroyed his wartime files to avoid arrest, but one copy of his American report survived, buried in the archives of the Luftwaffe Research Institute. When Allied troops occupied Germany, they seized millions of technical documents. Among them, Becker's report. A young U.S. Army intelligence officer, Captain Robert Evans, found it during a sweep of a storage depot near Göttingen. He was fluent in German, and as he translated the first pages, he realized what he was reading. The captured engineer's tone was not arrogant or political. It was almost mournful, a eulogy for an industrial philosophy that had doomed itself by refusing to evolve. Evans forwarded the report to Wright Field, Ohio, home of the U.S. Army Air Technical Service Command. There, it was quietly reclassified as Restricted Technical Intelligence, Axis Evaluation 1944. Post-war analysts studied Becker's words and realized he had predicted not just the outcome of the air war, but the foundation of modern military logistics: standardization, modularity, interchangeability. The same ideas that would define the Cold War, the Jet Age, and eventually the Digital Revolution. Becker had seen the future from inside the ruins of his own civilization. 20 years later, in 1965, a historian from MIT named Dr. Harold Sherman tracked down Becker's surviving family. He found the engineer, older, frail, but alive, living quietly in Munich, teaching mechanical design at a small technical institute. Sherman showed him the American reprint of his report. Becker read the English translation slowly, smiling faintly at how his words had been repurposed into an academic study of production theory. He said softly, "They understood what we refused to see, that in the modern age, machinery is not built by men, it is built by systems. And those systems reflect the values of the people who created them." Sherman asked, "And what values do you think won the war, Herr Becker?" Becker looked out the window for a long moment. "Openness," he said finally. "They shared information instead of hoarding it. They valued reliability over elegance. And they built things to be repaired, not worshipped." He paused. "That is why they conquered the air. Not through genius, but through humility." In the end, Becker's discovery was never about a single airplane. It was about a civilization that had learned to merge imagination with organization, freedom with precision. The Americans did not build the best fighter because they had better metal. They built it because they had better methods. Every rivet, every bolt, every interchangeable panel was a declaration that order defeats chaos, that cooperation defeats individual brilliance, and that the future belongs to those who can turn innovation into process. The P-47 wasn't just a machine. It was the industrial heartbeat of a democratic nation, engineered to outproduce, outlast, and ultimately outthink its enemies. If you've made it this far, You now understand something few ever talk about, that wars are not only fought with weapons, but with philosophies. If you want to see more deep dives like this, stories buried beneath the machinery of history, where engineering meets destiny, make sure you like, subscribe, and turn on notifications. The next story will take you inside another forgotten secret of World War II, one that redefined the very meaning of technological dominance. Stay curious, because the truth, like Becker's report, is often buried under the rubble, waiting to be rediscovered.